This video tutorial will show users how to perform the assay for the measurement of lactulose using the Megazyme Lactulose assay kit. The kit provides 50 assays and is supplied with the kit reagents and the kit data booklet. The assay is specific for the measurement of lactulose, especially in milk-based samples. The process of the lactulose assay procedure begins with sample preparation and extraction. This involves diluting or dissolving the sample in water, followed by clarification using K-LACTUL reagents. In the clarified sample, lactulose and lactose are simultaneously hydrolyzed by beta-galactosidase. Excess glucose is then removed by the enzymatic reactions of glucose oxidase and catalase. The sample is applied then to the enzymatic determination reactions to measure D-fructose. The results of this measurement are analysed and calculated as lactulose content in the sample. Simple automated data analysis can be performed using the Lactulose Kit MegaCalc application that is available to download from the Megazyme website. Here we describe the principle of the enzymatic reactions of the lactulose assay procedure. The reactions proceed with the simultaneous hydrolysis of lactose and lactulose by the enzyme beta-galactosidase to galactose, glucose and fructose. Excess glucose is then removed from the system by conversion to gluconic acid by the enzymes glucose oxidase and catalase in the presence of oxygen. After the removal of excess glucose, any residual glucose and fructose are phosphorylated by the enzyme hexokinase in the presence of ATP to glucose 6-phosphate and fructose 6-phosphate respectively, with the simultaneous formation of ADP. Glucose 6-phosphate is oxidized by the enzyme glucose 6-phosphate dehydrogenase in the presence of NADP to gluconate 6-phosphate with the formation of reduced NADP. The gluconate 6-phosphate product is immediately converted to ribulose 5-phosphate, carbon dioxide and a further molecule of NADPH by the enzyme 6-phosphogluconate dehydrogenase. On completion of this reaction, fructose 6-phosphate is converted to glucose 6-phosphate by phosphoglucose isomerase. The glucose 6-phosphate formed enters the reactions catalyzed by glucose 6-phosphate dehydrogenase and 6-phosphogluconate dehydrogenase. The amount of NADPH formed is stoichiometric to twice the amount of lactulose, as 2 molecules of NADPH are produced for every fructose molecule originating from the lactulose in the sample. Prior to sample analyses, the kit components should be prepared as described in the kit booklet. All of the kit components except bottle 2 and bottle 4 are used as supplied. The contents of bottle 2 should be dissolved in 6 ml of distilled water. Mixing thoroughly to ensure that the contents are fully dissolved. For storage, divide the solution into appropriately sized aliquots and store in polypropylene tubes at -20 degrees Celsius. The contents of bottle 4 should be dissolved in 12 ml of distilled water. Again, mixing thoroughly to ensure that the contents are fully dissolved. This solution is stable for greater than 1 year when stored at 4 degrees Celsius or greater than 2 years when stored at -20 degrees Celsius. The lactulose assay procedure requires some general chemicals that are not supplied with the kit. These are sodium phosphate buffer containing magnesium sulfate, sodium acetate buffer, TEA buffer containing magnesium sulfate, concentrated K-LACTUL solution, concentrated K-LACTUL solution, sodium hydroxide, octanol, and hydrogen peroxide. Details of how to prepare each of these reagents are provided in the kit booklet. To perform the assay procedure for the measurement of lactulose, samples are applied to the sample preparation procedure, followed by the enzymatic determination reactions. In step 1 of the sample preparation procedure, samples are clarified using K-LACTUL reagents. In this procedure, the components listed in the table should be pipetted into a 1.5 ml microfuge tube. It is important that the components are added in the order that they appear in the table and that the sample is thoroughly mixed after each addition. This demonstration will show the processing of 2 milk samples. The lactulose standard that is supplied with the kit can also be used as a control sample to check that the kit assay is working as expected and being performed correctly. To the sample tubes, firstly add sodium phosphate buffer and distilled water. After the addition of distilled water, mix each sample solution thoroughly by vortex. Now add the first milk sample to one of the sample tubes. Again, mix the sample solution thoroughly by vortex. Now add the second milk sample to the second sample tube. And mix this sample solution thoroughly by vortex. Now add concentrated K-LACTUL 2 solution to all sample tubes. Mix the sample solutions again thoroughly by vortex. Now add concentrated K-LACTUL 1 solution to the sample reactions. It is extremely important that concentrated K-LACTUL 2 solution is added before concentrated K-LACTUL 1 solution. After the addition of concentrated K-LACTUL 1 solution, mix the sample tubes thoroughly by vortex and then centrifuge at approximately 13,000 RPM for 10 minutes in a microfuge. Step 2 of the sample preparation procedure involves hydrolysis of lactulose followed by the removal of excess glucose. Each sample that was extracted in step 1 is applied to 2 reactions in step 2, a sample reaction and a blank reaction. As in step 1, the components listed in the table should be pipetted into a 1.5 milliliter screw cap microfuge tube. Again, it is important that the components are added in the order that they appear in the table and that the sample is thoroughly mixed after the addition of each component. After centrifugation of the samples in step 1, carefully pipette 0.5 milliliters of the clear supernatant of each sample into both a sample reaction tube and also a blank reaction tube. After pipetting the sample supernatants, then pipette sodium acetate into all the sample tubes. And mix all reaction solutions thoroughly by vortex. Suspension 1, beta-galactosidase, is then added only to the sample reaction tubes. And mix the sample reaction tubes thoroughly by vortex. Distilled water is then added to the blank reaction tubes. And mix thoroughly by vortex. All reaction tubes are then incubated in a water bath set at 40 degrees Celsius for 1 hour. After the 1 hour incubation, the remaining components of step 2 are added to all reaction solutions to remove any excess glucose. It is important that the assay components are added in the order that they appear in the table and that samples are thoroughly mixed after the addition of each component. To all reaction solutions, first add TEA buffer. And mix the reaction solutions thoroughly by vortex. Then add sodium hydroxide to all reaction solutions. And mix all reaction solutions thoroughly by vortex. Now add octanol to all reaction solutions. And mix the reaction solutions thoroughly by vortex. Next, add suspension 2 containing glucose oxidase and catalase mixture to all the reaction solutions. Mix all of the reaction solutions thoroughly by vortex. Next, add the final assay component in this step, hydrogen peroxide, to all reaction solutions. After the addition of this component to the reaction solution, it is important that the sample tubes are capped immediately. Then mix all the reaction solutions thoroughly by vortex. After the addition of hydrogen peroxide and thorough mixing of the reaction solutions, incubate all reaction solutions at 40 degrees Celsius in a water bath for 15 minutes. After the 15-minute incubation, centrifuge all reaction solutions in a microfuge at approximately 13,000 RPM for 10 minutes. After centrifugation of the reaction solutions, slowly release the caps of the microfuge tubes. This is an important step and is to allow the slow and safe release of any pressure that may have built up in the tubes generated by the glucose oxidase and catalase reactions. The clear supernatants of the sample and blank reactions are used as sample solutions in the enzymatic determination reaction procedure. To perform this procedure, pipette assay components into 1 cm path length cuvettes using the volumes and order of addition as shown in the table. First, carefully pipette 1 milliliter of sample reaction supernatant and transfer this to a sample cuvette. Similarly, carefully pipette 1 milliliter of blank reaction supernatant and transfer this to a blank cuvette. Then add solution 3, buffer, to all cuvettes. Now add solution 4 containing NADP and ATP to all cuvettes. Now mix all the cuvettes thoroughly and incubate for approximately 3 minutes before taking the first absorbance reading, A1, of all the reaction solutions. After the incubation, read the absorbance values of all the solutions at 340 nanometers. This is reading A1. After recording the absorbance readings A1 of each solution, add suspension 5 containing hexokinase and glucose 6-phosphate dehydrogenase to each cuvette. Then add suspension 6 containing 6-phosphogluconate dehydrogenase to each cuvette. Mix all of the reaction solutions thoroughly and incubate for approximately 10 minutes before reading the second absorbance. After the incubation, record the second absorbance reading of each solution. This is reading A2. After recording the absorbance readings A2, add suspension 7 containing phosphoglucose isomerase to each cuvette. Mix the solutions thoroughly and incubate for approximately 15 minutes. After the incubation, record the final absorbance reading of each solution. This is reading A3. The absorbance readings A1, A2 and A3 of the sample and blank reactions are used to calculate the lactulose concentration in the original samples. The calculation of lactulose content in samples applied to the lactulose assay can be performed manually as described in the calculation section of the kit booklet. Alternatively, results analysis can be performed using the Lactulose Megacalc application that is available to download from the Megazyme website. This is an Excel-based spreadsheet that allows simple automated calculation of results from raw data. The first worksheet of the Megacalc shows the instruction page that details how to fill out the Megacalc spreadsheet. To perform results analysis, open the Megacalc worksheet. First, input the sample details of the experiment. Then, for each sample, input the sample identifier and the absorbance values for the sample reaction test and the blank reaction test. If a sample volume other than 1 milliliter, or if an additional dilution of the sample was performed, then input the new values. When all of the raw data has been input, the concentration of lactulose in the sample is automatically calculated and given as grams per litre in the original sample. For solid samples, input the concentration in grams per litre of the original sample when it was extracted. The concentration of lactulose in the solid samples is then automatically calculated and provided as grams per 100 grams in the original sample. Reagents included in the Megazyme lactulose assay kit can be prepared for the measurement of lactulose using the procedure described by ISO method 11285-2004. However, the slightly modified advanced method developed by Megazyme, that is both more sensitive and rapid, features an additional enzyme, 6-phosphogluconate dehydrogenase, that results in a twofold increase in sensitivity. Details of how to prepare each of the reagents for the ISO method are provided in the kit booklet.